Hello everyone, and let's have a quick look at this question. So, car starts from rest at traffic lights and moves along a straight road with constant acceleration. Motorcycle traveling parallel to the car with constant speed 16 passes through the same traffic light exactly 1.6 seconds after the car starts to move. The time the car starts to move is denoted by t seconds. Determine the values of t at which the car and the motorcycle have the same distance from the traffic lights. Okay, so here's the car situation, and there's the motorcycle. So what we got is the car is moving with constant acceleration at 4, and starts initially from rest, so that's 0. We're going to call that displacement SC for displacement for car, and the time we're going to call it t. For the motorbike, it is a SUVAT question, but with here acceleration is 0. U equals V equals 16 since it's going at a constant speed. We're going to call the displacement as displacement of the motorcycle, and the time is 1.5 seconds after this, so it's going to be t minus 1.5. okay, and because we got a, u, s and t, we're going to use the formula s equals ut plus half at squared. Okay, so let's set this up. We know for the car SC is going to equal U, which is 0. So 0 times anything is 0. So we just going to get half times 4, which is 2t squared. So that's just going to be 2t squared. And we know that the displacement for the motorbike is going to be, well, A is 0, so all that's going to be 0. So it's just going to be 16 multiplied by t minus 1.5. Now, because we want where the both distances are at the same from the traffic lights, we're going to equate those two. So we're going to get an equation 2t squared equals, now I'm going to expand that out to give me 16t. 16 times 1.5, 1 times 16, 16, half of 16, 8, added together is minus 24. Bring that to one side, you're going to get 2t squared minus 16t plus 24 equals 0. Just to make it easier here, since it's all equal to 0, let's just divide everything by 2. So t squared minus 8t plus 12 is equal to 0. Now we can easily factorize here, where we can see that two numbers times together to give me 12 and add together to give me minus 8 is going to be 2 and 6. So 2, and they're both going to be negative, minus 2 and minus 6. So the 2 times t is going to equal to 2 seconds, and t is equal to 6 seconds. Okay, so that's the first one done. We find those 2 times. And these two values of t are denoted t1, t2, where t1 is less than t2. So let's call that t1 and call that t2. Describe the relative positions of the car and the motorbike when time is between t1 and t2. Okay, and the best way to do this is probably to do a quick sketch of this graph. So what's happening? So if we sketch these two displacement graphs, if I just draw them quickly here, forgot my space. Now this is a quadratic, so that is going to be squared. We're not interested in t values less than 0, so this graph will go like that, and then gradually go up. And then I might as well do the motorbike in a different color. This is a straight line, which is going to have a gradient of 16t, and the intercept is minus 8. So let's put the minus 8 here, and then if we draw this straight line, we've got that situation. So that first point where the displacement is the same is called T1, and this second point is T2, which is again the same displacement from these graphs. So this is the motorbike, this is the car, and as you can see, at that point the motorbike overtakes the car, and then at this point the car then, as it's accelerating, will overtake the motorbike. So I'll put that as motorbike and go back to here. This is car. The car will then overtake it back. So in this situation where the timing is between T1 and T2, I'm going to put the motorcycle is in front of the car. Okay, you can easily see that from the graph how it's going. So now third part, sorry, C, it goes determine the maximum distance between the car and the motorcycle. So what we could do here is, well, you could do this in a couple of ways. So it's asking for that distance, which is the maximum, which happens here, the distance between those. But I would probably do this by just simple differentiation. Once you've got that equation, okay, so if you then differentiate that, just trying to think, that will be probably, yeah, I'm going to call this function function f of t, and that will be 2t squared minus 16t plus 24, and if I factorize that, differentiate that with respect to t to the power down 4t to 1 to the power down, that'll be 16, and I want to know the value of the stationary point. So if I make that equal to 0, so ft equal to 0 to give me the stationary point, I'll get 4t minus 16 equals 0, 4t will equal 16, and therefore t will equal 4 seconds. So at 4 seconds you've got to get a situation where that is going to, the distance between the motorbike and the car is going to be at its maximum. Find the maximum distance between the car. So that's when it's going to occur. Okay, and because it's positive quadratic, you know that that is going to be a curve like that, and that's going to give you the stationary point there. Okay, so let's just have a look, maximum distance between the two lines. So let's have a look at sub that in. So you can now sub that in the equation, which is this one. So put f of 4 in there in the function to give the maximum. So you got 2 4 squared minus 16 times 4 plus 24. So you're going to get 1632 minus 64 if I put this, just give me 1 second. I'm just trying to f of t, just forgot it in the right function. 16 squared doublet 32, yeah, and that's going to give me plus 24, and that's going to be, yeah, because I am going to get a negative value, but don't worry about that. So if I just add those up, I'll get that plus that will give me the 56 minus the 64, which gives me a minus 8. And because it is a distance, we can just take the modulo of that. So therefore, the maximum distance between the two will be 8 meters. So this is just in terms of displacement, but we can just say that the positive distance between them is going to be, the maximum distance between them will be 8 meters. Okay, hope that helps. Thank you.